Hey everyone. So for those of you who missed our Google Meet yesterday, I thought maybe you would want to know what we worked on and it could help you for the quiz just to see all this new trig stuff in a different way. We talked about how the way that you've been learning it through the videos is super important and it really helps with your understanding. And although we don't like trigs because trigs tend to hinder your understanding, in this case I find it really helpful and useful and can take you through to grade 12 math and beyond. It's something that I would still use. And when I help my sister with her math, I also would use this method, so I think it's just important to know. So we're going to go through it. So in this case, what we've been learning so far is your understanding is this rotational trigonometry and how you have this angle that moves in this direction, starting from 0 degrees, going to our kind of like benchmarkers of 90 degrees, 180 degrees, 270, and then a full rotation would get us back to 360. So it has a couple of meanings. And we talk about how, let's see, if you put your angle at, I don't know, let's go with 80 degrees. So that's not what I wanted. There we go. 80 degrees. Somewhere like this. Let's call that 80 degrees. And you make your triangle with the x-axis. There we go. Much better. So here's your 80-degree angle, and you make your triangle with the x-axis. And we can find our primary trig ratios using this positive x and a positive y value, whatever length that is, and we have our radius up there. And we know that that changes if our angle happens to be larger than 90 or larger than 180. It can go to different quadrants. Let's say down here, we could have triangles down there, which would give us negative x values, negative y values, and radius is always positive, and that changes whether our sine, our cos, or our tan is positive. And you can work through it, and that is great, and it's important to understand that. But another thing that we tend to use in math is called the CAST rule. So first off, it's important to remember that quadrant 1 starts up here in the positive quadrant. Quadrant 2 is over here. Quadrant 3 is down there. Quadrant 4 is down there. I mean, we could use numbers instead of Roman numerals, but it doesn't really matter. I guess just traditionally it is Roman numerals. But if you would rather just number it 1, 2, 3, 4, that's fine with me too. But then we have this new rule that we call the CAST rule. So, well, it's not new, but new to you. So in the CAST rule, those letters are representing which primary trig ratio is positive in those quadrants. So in the first one, in quadrant number 1, where it's A stands for all. All of them are positive. Sine's positive, cos and tan is. Whether you do opposite over hypotenuse or adjacent over hypotenuse or opposite over adjacent, they're always going to be positive because of our positive x, y, and radius. Moving over to quadrant 2, the S quadrant stands for sine. Only sine is positive here. Tan will be negative and cos will be negative. Again, because of that negative x value. Down here, only tan will be positive, which makes sense because both x and y are negative, and they'll end up canceling out. And finally, over here, we end up with cos being the only one that's positive. So it's just a handy way to help you remember. Of course, you understand it, but it is a quick way to understand how many solutions are you going to have and where are they going to fall. So let's say, for one quick example, we want to do, sine theta. I'm going to do ones that aren't these special triangles, so that way you can work through that on your own on the quiz. So let's say that sine theta equals to 0.75. So the first thing that we want to do is look at our CAST rule and say, well, sine is positive, right? I can for sure know that that's a positive number. And let's say I want that my theta to be in between 0 and 360, which means that we're just doing one rotation of this graph. So if theta is in between 0 and 360, then we say, okay, based on my CAST rule, where is sine positive? Well, here it's all positive, so definitely I'll have a solution in quadrant 1, and sine's also positive here because that's where the S is. So quadrant 1 and quadrant 2 are the two spots where we're going to have a solution. So step number 1 would be to find your angle, find the first angle, which basically we always kind of want to find that acute angle that falls in quadrant 1 to help us base our other answers off. So to find that angle, we can use our handy dandy second function rule to find angles. That's not new to you. 0.75. And you plug it into your calculator and you get, you can do this along with me. Let's round it and say 49 degrees. Really, you should have 48.6, but 49 degrees. Okay, so that's telling us right there, 49 degrees, if we use our rules that we know, that would fall into this quadrant right here. So we already have answer number 1 checked off. But how are we going to find the answer in quadrant number 2? We'll draw another one over here to help us out. So we basically found answer number 1 already over here. This is our 49 degrees. Done. We also have another answer over here that also has an angle of 49 degrees because that angle that we found is going to be true for all the quadrants, but the overall angle still has to start from 0 and travel to up to this point. So how many degrees is that? Well, it almost got to 180, but not quite. It's 49 degrees short. So to find angle number 2, okay, we can call that angle 1 over here. Angle 2 would be 180 minus 49. Again, you can take your calculator or you can do mental math and you end up with 131 degrees. So your final answer for a question that says, you know, find all the angles or all the solutions between 0 to 360 is going to be 49 degrees and 131 degrees. Awesome. So what happened if I said instead that I wanted to find sine theta equals negative 0.75? Okay, so now that changes things because based on our cast rule, we would go through and say, well, where is sine negative? Okay, well, I know it's positive in the top two, which means it has to be negative in the bottom two. So how does that change our answer if we have a triangle down here and down here? Well, step 1 is still going to be to find the acute angle using the positive. So I still want to do theta is sine inverse of positive 0.75 because if you plug in the negative, it's going to give you, it'll give you one of these two answers here, but then you're going to have to work backwards to help you find out how do I find that second angle. So I think the best strategy is always to use the positive, and we know that's 49 degrees. And yes, we know that's over there, so it's not our solution. It's not the final answer. It's just going to help us to say, well, this is 49 degrees, and so is this inside there. So to find our first angle here, we would start from 0 degrees. We'd go past 90, past 180, and we just went 49 degrees past 180. So for angle number 1, I would say 180 degrees plus 49. And when we do that, we get 229 degrees. Makes sense. And for our second angle, start at 0, we go past here, and we almost get to 360 degrees, almost a full rotation, but not quite. So we would say we're 49 degrees short of 360, or 360 minus 49 degrees, to give us 311 degrees. So we use this 49 to help us get our two solutions. Hopefully that's making a little bit more sense, and the cast rule is helpful. So the last thing we want to do is to take a look and see, what if I don't have, this right over here, boundaries between 0 and 360? What if we change them? The one in your quiz has definitely changed. We added some negative degrees in there. We went way past 360. What does that look like? So normally when we go through our quadrants, we have 0, 90, 180, 270, and 360. But if we go backwards in the backwards direction, we talked about this last week. I think I posted a video about it. This is also now negative 90 degrees, also negative, not 270, negative 180, negative 270, and it's also negative 360. And what happens if we take a full rotation in the positive direction and we go around 0, 90, 180, 270, we get to 360 and we keep going? Well, now we add another 90 degrees. So we also get 450 and we go again another 90 degrees and we get 540, and you could really keep going. So you've got to, I guess, work with these boundaries that you are given here. So if I told you I want to find the solutions where cos theta is equal to negative 0.81, random question, and I want to have theta in between negative 270 degrees and where do I want to go? 540. That's a pretty big range there, so we want to know how many solutions are we going to have. So we'll draw ourselves a quadrant here, and we'll do our labeling just like we did before. So this is negative 360 or 0 or 360. Down here we said it's negative 90 and also 270. This one here is negative 180 times 180 times or 180 or 540 degrees. And up at the top here we know it's negative 270 or 90 or 450, depending how we start. So if this is our range, and I guess I'll put in the cast rule here on the outside so we can refer to that later. So let's start our rotation. So we're starting at negative 270. That's our beginning, and this is our end. So we're starting at negative 270, and we're going around to negative 180, negative 90, 0. We've now finally made it to 0. Got to keep going. 90, 180, 270, 360, but we have to go past 360 to get to 450, and finally we end at 540. So we have a couple of rotations in there. Okay, so how do we use that? Well, we want to know where cos is negative. All right, so in this case, we want to figure out where is cos negative. So we look at our cast rule and we decide, okay, well, we know that cos is positive on the right side here, so it's going to definitely be negative in the S and the T quadrants. Okay, so the big question now here is how many solutions are you going to have? Okay, let's count. I'll get a different color here. So in the S quadrant, we know we passed through this time, and this time. So that's 3 solutions there already. And we also know that we passed through 2 times down below there. So that's 5 in total, which means by the end of this, you should have 5 solutions when you give your answer. Obviously, that's going to change depending on the question. Like, that doesn't mean every time you have 5 answers, it's going to change. The one on your quiz could have a different amount. But for this specific question, we do this. So I'll walk you through like how to get one of the answers, and I'll let you do the rest on your own. So for here, we would go to step number 1. We would say find the acute angle. So I would say theta equals cos inverse of positive 0.81, because I want to find out the small angle that we're going to use to help us out. So cos inverse 0.81 gets us to 36 degrees when we round. Lovely. Okay, so let's find angle number, the first one from the first rotation. So I'm going to go with this color, and we'll call this angle number 1. So in that rotation, we know that it's in this quadrant, and we know that the angle from the first rotation is negative 180. So to find angle number 1, I would say negative 180 subtract 36 to get negative 180 subtract 36 to get negative 216 degrees. Okay, we'll try another one. So in this situation right here, we know that's now positive 180. So maybe I'll call that 1. I'll call that 2. So I would do positive 180 minus 36. Same thing for angle 3. Now that it's 540, I would do 540 minus 36. Might as well do the rest of them. For 4 and 5, we'll go with, this is number 4 over here. So number 4 is from the first time around. So we started at negative 270, then we went to negative 180. So here I would now go back to number 4, and I would say it's a little bit bigger. So we would say negative 180 plus 36, or whatever your angle happens to be. And for angle number 5, we'll call that this one there from our second time around, which means that now we're at positive 180 again. So I would do positive 180 plus. And then you have all your answers. So just to have one final little wrap up, and then I will end this video. It's getting kind of long. So for our original 0, 90, 180, 360, we always want to base our angles off of the x and y axis. So if your angle falls in here, we'll call this, okay, if your angle falls in quadrant 2, then you do 180 minus your angle, or whatever this reference angle happens to be, whatever that x-axis angle is. If you have an angle in quadrant 3, that means that your angle is a little bit bigger than this value on the x-axis, so you do 180 plus your angle. If your angle falls in quadrant 4, then it's just short of being at this value over here. So we would normally do, because it's 360 minus your angle, or if you're only at the part where it's reaching 0, then I would say 0 minus the angle. And if you go back around and get to, because usually your acute angle is just going to fall in quadrant number 1, but if you're going on a second rotation, it could be 0 plus the angle, it could be 360 plus the angle, it just depends. So I guess keep in mind that you're always kind of using those x-axis or the horizontal values to find your graph, find your angle using the acute angle. I hope that helps and didn't make it more confusing. I think overall it should be helpful and help to guide you with using these bigger degrees and more rotations. I know trig is weird. Please let me know if you have any questions. Good luck.